Hello students, welcome to Anne's classes. Let's do rational numbers exercise 1C. Exercise 1C is on page number 18. Question 8, verify. Now what do we have to verify? That x plus y, the whole thing within brackets into z is equal to x into z plus y into z. That means what we have on the left hand side should be equal to what we have on the right hand side. That is the meaning of verify, that they are equal. Now this we already know. When we have a multiplication like this, then how do we do this? We say z into x plus z into y. That's the same thing here. Instead, z into x plus z into y. So we are going to verify that this is so, that this is equal, left hand side is equal to right hand side by substituting x for 4 by 5, y minus 2 by 3 and z minus 4. So here let's write that down. So here we have x plus y in brackets into z. Now this is equal to the right hand side, which is x into z plus y into z. Now we're going to substitute the values here. How much is x? X is 4 by 5 plus, and what is y? Minus 2 by 3 into z, and z is minus 4. So first we're going to work out the left hand side. So that is what we have here, the left hand side. So this is the left hand side and LHS stands for that, and we're going to work this out. Now if you look at this, 4 by 5 plus minus 2 by 3, we have to add up the two rational numbers. Denominators are different. So we must find the LCM of 5 and 3. So let's do that. LCM of 5 and 3. 5 ones are 5, bring down 3. Now use 3 here, 1 and 1. So what is the LCM? 5 into 3, which is 15. So we're going to use this here. So this will be 15. Now look at the first rational number, 4 by 5. The denominator is 5. 5 into 3 is 15. So let's write that there, 5 into 3. So multiply 4 also into 3. 4 3s are 12 plus, now here we have 2 minus 2 by 3, denominator is 3. 3 into 5 is 15. So let's write that 3 into 5 is 15. So multiply 2 also by 5, it becomes 10, and that is minus 10 into minus 4. So here what do we get? 12 minus 10 by 15 into minus 4. 12 minus 10 is 2, denominator is 15 into minus 4. Now minus 4, we can give it the denominator 1. There's nothing to be cancelled. So we multiply the numerators. Minus 4 into 2 is minus 8 and 15 into 1 is 15. So on the left hand side, we've got minus 8 by 15. Now let's see on the right hand side whether we get the same answer. So this is the right hand side which we are going to work out now. So the right hand side, let's work out. So substitute the values. X is how much? 4 by 5 into Z is minus 4 plus Y minus 2 by 3 into Z again, which is minus 4. So here we need to work out. So this will have the denominator 1, nothing to cancel. So multiply the numerators. 4 into minus 4 is minus 16 by 5 into 1 is 5 plus minus 2 into minus 4. Minus into minus is plus. 2 4s are 8. And here let's give it the denominator 1. So 3 1s are 3. Now let's look at these two rational numbers. We have to add them up. Denominators are different. We have to find the LCM of the denominators, which is already found here, and it is 15. So let's use that. So this is 15. And let's look at the first rational number. Minus 16 by 5. 5 into 3 is 15. So multiply minus 16 into 3, which is minus 48. Plus, go to the next one. 8 by 3, 3 into 5 is 15. So let's write that, 3 5s are 15. So multiply 8 also by 5. 8 5s are 40. So here what do we have? Minus 48 plus 40, signs are different. Put the sign of the bigger number and subtract. 48 minus 40 is 8 and 15 we have. So here what's the answer on the right hand side? Minus 8 by 15. And on the left hand side, minus 8 by 15. That means left hand side is equal to the right hand side, and we have verified that. Okay, so for the first question, we have verified and shown that the answers on the left hand side and the right hand side are the same. Question 2. Here the values of x, y and z are different. So let's substitute these values for x, y and z. So on the left hand side we have x plus y into z, and this is equal to, on the right hand side we have x into z plus y into z. So now the left hand side is what we are going to do first. So LHS means left hand side, and we're going to do that. So what is the value of x? X is 2. 2 plus y is 4 by 5. 2 plus 4 by 5 into z, which is 3 by minus 10. Now here let's give to the denominator 1, and now let's add up these two rational numbers. The denominator is 5, which is the LCM now. So 1 into 5, so 2 into 5. 2 5s are 10, plus 5 into 1 is 5, so 4 into 1 is 4. So you can write the same thing, plus 4. So 10 plus 4 by 5 into 3 by minus 10. 10 plus 4 is 14. 14 by 5 into 3 by minus 10. Now here we can cancel 14 and 10 by 2. So this will be 2 sevens are 14, 2 fives are 10. Now let's multiply the numerators. Numerators 7 threes are 21. Denominator 5 into 5 is 25 minus 25. So on the left hand side we have 21 by minus 25. Now here let's look at the right hand side and see what we have. So x into z. So how much is x? X is 2 into z. Z is 3 by minus 10 plus y. How much is y? 4 by 5 into z, which is 3 by minus 10. Now here 2 by 1. Okay. Now 2 by 1 into 3 by minus 10. We can cancel 2 and minus 10. That is 2 and 10. 2 ones are 2. 2 fives are 10. So what do we have here? Multiply the numerators. 1 into 3 is 3. 1 into minus 5 is minus 5. Plus, now on the other side, let's see what we can cancel. We can cancel 4 and 10 by 2. 2 twos are 4, 2 fives are 10. Nothing else to cancel, so let's multiply the numerators. 2 threes are 6 and 5 fives are 25 minus 25. Now here for addition and subtraction, we have to have the denominator positive. So let's move the minus sign to the numerator. Minus 3 by 5 plus minus 6 by 25. Now here we have to find the LCM of 5 and 25. 5 ones are 5, 5 fives are 25. Carry on 5, 1 and 1. So LCM is equal to 5 into 5, which is 25. So let's use this as the common denominator here. So here this will be 25. And the first rational number, the denominator is 5. So 5 fives are 25. Multiply this also by 5. 3 fives are 15 minus 15. Plus, on the other side, we have 25 into 1. It's the same thing. So we can write minus 6 as it is. So that will be minus 6. So this is minus 15 minus 6 by 25. So minus 15 minus 6 signs are the same. So we put the same sign and we add 15 plus 6 is 21 by 25. So now on the right hand side we have minus 21 by 25, and on the left hand side we have 21 by minus 25, which can also be written as minus 21 by 25. This one's value will not change. So here what have we shown? That the left hand side is equal to the right hand side, and hence we have verified. Question 9. Here also now we have been asked to verify that the left hand side is equal to the right hand side if all these values are substituted. So let's do that. So let's write that down. So x into y minus z. This is on the left hand side, and on the right hand side we have x into y minus x into z. Now here we know that when we multiply it will be x into y. So we have x into y minus x into z, x into z. So we're going to substitute all these values here. So here x is equal to 4 by 5 into y is minus 7 by 4. So let's write that minus 7 by 4 minus z is 3. So first let's work out this, which is the left hand side. So let's write this. This is the left hand side and we're going to work out this first. So what is within brackets we have to work out. So let's give this the denominator 1. So before the bracket we have 4 by 5. Right now there is no change. We write it as it is. Now here within brackets, look at the denominators 4 and 1. So our LCM is 4. So look at the first one here. Since the denominator is 4 and LCM is also 4, we can write this as it is. Minus 7 minus, look at the second rational number, denominator is 1. 1 into 4 is 4. So 3 into 4. 3 fours are 12. So we have minus 12 then. Let's continue. This is 4 by 5 into minus 7 minus 12. The signs are the same. So we put the same sign and we add. 7 plus 12 is 19. So we have minus 19 and in the denominator we have 4. Now let's cancel. We can cancel 4 and 4. So what do we have left now? In the numerator minus 19. In the denominator 5. So this is what we got on the left hand side. Now let's work out the right hand side and see what we have on the right hand side. So we begin with x into y. So how much is x? 4 by 5 into y, which is minus 7 by 4 minus x into z. So x is 4 by 5 into z is equal to 3. So now we're going to work this out. So this will be 4 by 5 into minus 7 by 4. We can cancel 4 and 4. So what is left is minus 7 by 5 minus, let's go to the other side. 3 will have the denominator 1. Now there's nothing to be cancelled. So let's multiply the numerators. 4 into 3. 4 threes are 12 and in the denominator 5 ones are 5. So now denominators are the same, so that will be the same LCM. When denominators are the same, numerators also will be the same. So we have minus 7 minus 12. Signs are the same. We put the same sign and we add. 7 plus 12 is 19 and the denominator is 5. So here what do we have now? On the right hand side we have minus 19 by 5. On the left also we have minus 19 by 5. So what have we proved? That the left hand side is equal to the right hand side. So we have verified this. Question 2. Here also we have to show that verification. That is x into y minus z. We have to show that it's equal to x into y minus x into z. Again, let's substitute all the values here. So this is the left hand side that we are working out now. LHS is left hand side. So x is 3 by 4. 3 by 4 into, now y is 8 by 9. So let's write that 8 by 9 minus z is minus 5. So this is the left hand side that we are working out first. So 3 by 4, I'm going to write it as it is. Now look at what is within brackets. 8 by 9 minus 5. So let's give this the denominator 1. So here the LCM is going to be 1. So LCM is going to be 9. 1 and 9 are the denominators. So LCM is going to be 9. Now 9 into 1 is 9. So 9 and 9 are the same. So we write 8 also as it is. 8 minus, now here we have minus 5 by 1. 1 into 9 is 9. So 1 into 9, so we multiply 5 also by 9. 5 nines are 45 and we have a minus sign, minus 45. So this will be 3 by 4 into, okay, now 8 minus 45 is 8 plus 45 because minus into minus is plus by 9. So this is still within brackets. So this is 3 by 4 into 45 plus 8 is 53. by 9. Now let's cancel 3 and 9. 3 ones are 3, 3 threes are 9. So in the numerator, what do we have? We just have 53, and in the denominator, we have 4 threes are 12. Now let's work the right hand side. X is 3 by 4, x into y. So 3 by 4 into 8 by 9 minus x into z. 3 by 4 into z is minus 5. So here, let's see what we can cancel. I can cancel 3 and 9. 3 threes are 9. I can cancel 4 and 8. 4 twos are 8. So in my numerator, I have 2, denominator 3. So 2 by 3 minus, look at the other side, 3 by 4 into minus 5. Let's give this the denominator 1. So minus 5 by 1. There's nothing to be cancelled. So we multiply the numerators. Minus into minus is plus. So let's change this to plus. And 3 into 5 is 15. Then the denominators, 4 ones are 4. So here what do? We find the LCM of 3 and 4. 3 and 4, let's use 3 in the beginning. 3 ones are 3, bring down 4. Now use 2. 1, 2 twos are 4, continue 2, 1 and 1. So the LCM here is 3 into 2 into 2. 3 twos are 6, 6 twos are 12. So that's our LCM here, 12. Look at the first denominator, 3. 3 fours are 12. So 2 fours are 8. Plus 4 into 3 is 12. So 15 into 3. 15 into 3 is 45. 8 plus 45 is 53 and the denominator is 12. So on the right hand side we have 53 by 12. On the left also we have 53 by 12. So right hand side is this, left hand side is this. So as you can see, left hand side is equal to the right hand side. That means we have verified. Left hand side is equal to RHS. Hence verified. Question 10. Name the multiplication property of rational numbers shown below. So we have been given rational numbers. We have to look carefully and identify which multiplication property is shown here. So here we have two rational numbers. There's an equal to sign and there are two more rational numbers. Look carefully and see. Rational numbers on the left hand side are the same as the rational numbers on the right hand side. The only difference is the order has been changed. So here 3 by 5 is written first, whereas here 3 by 5 is written second. So which property is shown here? Here the property that is shown is commutative property or commutativity. That means even if you change the order when you multiply, the product will be the same. Okay, so the property here is commutativity. Question 2. Now here we have three rational numbers on the left hand side. On the right hand side we have the same three rational numbers. Okay. Now here what you see, the second and the third rational number have been grouped together, whereas here the first and the second rational numbers have been grouped together. Whichever order you group them in, when you multiply three rational numbers, your answer is going to be the same. So which property is that? Property is associativity or the associative property, which says that when you have three rational numbers, even if you group them differently, your answer is going to be the same. Question 3. Now here we have a group of rational numbers. There are two rational numbers multiplied by one rational number here. Now when you have to do this multiplication, we do 4 by 5 into 3 by minus 8. We have it here, plus 4 by 5 into minus 4 by 7. So what have we done here? We have distributed it here. Okay, and this is possible only if this is plus or minus. That means the multiplication of rational numbers is distributive only over their addition or subtraction. So what is the property here? Distributivity or the distributive property. Next one here, minus 7 by 5 into 5 by minus 7 is equal to 1. When you work this out, you get 1. So what do you see here? This is a rational number. This is its reciprocal or the multiplicative inverse. So when you multiply a number and its multiplicative inverse, your answer is 1. That means this shows that in multiplication, you have a multiplicative inverse. This shows the existence of inverse. Okay, so a number can have its multiplicative inverse, that is its reciprocal. And when you multiply a number and its reciprocal, you get 1, which is the multiplicative identity. So here we are seeing a rational number into 1 is equal to 1 into the rational number. That means when you multiply any rational number by 1, you get back that same rational number. Here also, when 1 is multiplied by a rational number, you get back the same rational number. So 1 is the multiplicative identity. That means this is showing us the existence of identity. Question 11, fill in the blanks. The product of two positive rational numbers is always, okay, now let's take two positive rational numbers. 2 by 3, product means you multiply into 1 by 4. Let's multiply and see. Now here I can cancel 2 2s are 4. What do I get? 1 by 3 2s are 6. That means I took two positive rational numbers and my answer is positive. So the answer to this is the product of two positive rational numbers is always positive. Second one, the product of two negative rational numbers. So this time let's take two negative rational numbers and see. So minus 1 by 2 into minus 2 by 3. So both are negative. Let's see what our answer is. So here we have minus into minus, which will become plus. Multiply the numerators, 1 2s are 2. Multiply the denominators, 2 3s are 6. So what you see here, when you multiply two negative rational numbers, your answer is always positive. So the product of two negative rational numbers is always positive. If two rational numbers have opposite signs, then the product is always, let's work that out. So we'll take a positive rational number. Product means multiply. We'll take a negative rational number. Okay, now let's multiply and see. So in the numerator, we have 2 into minus 1, which is minus 2. 3 into 5, 15. So here, what did we do? We took one positive, one negative, and we found the product. The answer is negative. Even if you change this into this number being negative and you multiply, your answer is negative. So if two rational numbers have opposite signs, then their product is always negative. Question 4. The reciprocal of a positive rational number is, let me take a positive rational number, 2 by 5. What is the reciprocal of this? 5 by 2. So this is positive. The reciprocal is also positive. Let's write that. And the reciprocal of a negative rational number is, now let's make this negative and see. So this is a negative rational number. The reciprocal will be 5 by minus 2, which is also negative. That means the reciprocal of a negative rational number is negative. Question 5. Rational number 0 has dash reciprocal. 0 has no reciprocal. There is no reciprocal for 0. So the answer is no. Next one, the product of a non-zero rational number and its reciprocal is what? Okay, so let's take a rational number 2 by 7. Let's write its reciprocal 7 by 2 and product means you multiply. Let's cancel. So 2 ones are 2, 2 ones are 2, 7 ones are 7, 7 ones are 7, 1 by 1 which is equal to 1. That means the product of a non-zero rational number and its reciprocal is always 1. Question 7. The numbers dash and dash are their own reciprocals. Which are the numbers that are their own reciprocals? Now suppose I take 2. What is the reciprocal of 2? 2 is 2 by 1, isn't it? Reciprocal will be 1 by 2. Suppose I take 17. What is the reciprocal of 17? 17 by 1 is 1 by 17. Now which are the two numbers, because there are two blanks, which are their own reciprocals? Now if I take 1, 1 by 1, the reciprocal is also 1 by 1. Okay, so the number 1, that is one answer. So 1 is its own reciprocal. What about the other number? What about minus 1? Minus 1 by 1. What is the reciprocal of this? 1 by minus 1, which is still the same. Minus sign, whether it's down or on top, it's the same. So the other number is minus 1. The last one. If m is the reciprocal of n, then the reciprocal of n will be m, isn't it? M is a reciprocal of n. That means the reciprocal of n will be m. Okay, children, with this we come to the end of this exercise. Thank you, children.